Okay, let me share my screen. Today we have lecture 3. Share mine. You should able see my screen, yeah? Josh, perfect. Do you have a question or just go ahead?
Yeah, I just wanted to check if you were gonna send the slides.
That's good. You always remind me. I will do it. Yes.
Sounds
Just
good.
just give me 1 second to do it. Yeah. Double check if there is any exercises with a solution. Okay, yeah, I have solutions. The exercise of the solutions should just give me 1 second to get. As I told you before, and all of you should know this, that the final version would be the version that will upload to the Blackboard, not the version that I'm sharing here. Because when I will upload it to the Blackboard, I will add the solutions exercises during the lecture. So I will name it here without solution, just so later you not to be confused. I will drop the exercises from this. I will get exercise 1 out and exercise 2 out. So this is without the exercises now. Yeah, I can see it. I will share it here. Without solution. Yeah. I send it in the chat if you want to have an access to this. As I said, I didn't include the exercises. Okay. Let me share my screen again. Okay, before I start, I'll ask you kindly that each one of you write present in the chat. So write present in the chat, and if you are using non-USV email, write your name with the present. Okay, perfect. I see that most of you that you have already. Eamon, how are you?
I'm good. How are you?
Good. So Do you have any feedback before we start concerning assignment 1 you want to share with us?
Assignment 1 was easy, except the last 2 parts. I mean, I completed the last 2 parts, but I was still having a little bit of confusion, so I did my best.
Yeah, concerning the
Yeah.
part when we talked about ER diagram and when we talk about database design, because we have already discussed that the prerequisite to start designing the database is list of requirements.
Yeah.
And sometimes it's not easy to understand the list of the requirements, because in reality, when we will get a list of requirements, we have to have an interview or a discussion with a stakeholder or the business owner. But in your case, you don't have this opportunity. So yes, I agree with you. Sometimes it's not easy to understand, but again, this will not, it will be okay, because based on your understanding, I am going to make an assessment. So don't worry about the assessment later.
Yeah, okay. Okay, thank you.
Alan, are you here? Alan?
Yeah. Hello. Can you hear me?
Yeah. I know all people whose first name is A, they will hate this. It always will be in the list, in the top of the list.
Yep.
So any feedback concerning assignment 1 you want to share with us?
Yeah, I think like the multiple choice wasn't too hard. I had some trouble with the last question as well. Yeah, understanding how the relationships worked.
Yeah, but finally you have already delivered the solution, yeah?
Yeah. I tried my best at it.
That's perfect. Okay, thank you so much, Alan. I think so next week maybe we can discuss the solution. I will try to double check your solution this week. And starting next week, maybe I'll publish a sample solution. Or maybe I can do it during the lecture I can see how we have based on the time management we have. But for sure, I will share with you the feedback and a sample solution. I'm using the word sample solution. This means that it can be more than one solution. For example, maybe some people have already made 2 relationships, some people have only 1 relationship, some people have already give a label for the relationship, not the same as I do. So does it mean that you are incorrect? Again, it is a design. So we shouldn't have all the same design. However, our design should include all the main concepts based on the requirement. So this is why I'm using the word, I will share with you a sample solution, which means that maybe other versions, they are also correct. I will take another, but not from the A people. Malik John? Malik? Can you hear us? See if Malik, yes. Do you have a mic, Malik, and you can talk with us using a mic, or you can't? I can't. It's okay. If there is any feedback other than what Eamon and Alan has already shared with us, you want to share with us? Okay, perfect. Thank you so much, Malik. So let's start with today's lecture. Before we start, let's give an overview of the last lecture. The aim from the overview of the last lecture, that if any person has any question from the last lecture, so he or she can start asking the question now before we start with the next lecture. So in the last lecture, we have already talked about how we can make this conceptual database design, which is the ER diagram. And then we talked about what is the different design phases before we start with the ER. And since this was what we have already discussed last time, conceptual database design, to do this design, we use ER model, entity relational model. And we said the next level is to have a logical design, which is what we are going to do today. The ER model talk more about the different entities, which is concepts that they have attributes. And we talk about how we can construct this ER model, how we can resemble the entity and their attributes and their relationships. We talked about relationships, and we talked about constraints in the relationships. We discussed two types of constraints. The first constraint we have already discussed, first type of constraint when we talk about cardinality constraint. And the second one when we talked about participation constraint. In the first one, we talked about one-to-one, one-to-many, many-to-many relationship. And the second one, we talked about fully or partially participation. And at the end of this, we talked about weak entity set. What is a weak entity set? Why we need a weak entity set? And we have already discussed that we should avoid the weak entity set whenever we can. And we have already practiced and exercised at the end of the lecture. Any questions so far concerning this? So I need 3 thumbs up to continue. Kura, do you have a question? Go ahead. And Josh. Kura first.
I just want, do you hear me, sir, Prof? Can you hear
Sorry?
me? Can you hear me?
Yeah, I hear you.
Okay. I just want to confirm the cardinals where I put it, example, student, or professor teaches student. So like 1:many, how can I put the 1 in the part of the professor or in the part of the student? I just confused where
Okay.
I put the cardinal.
Perfect. Okay, so if you have an entity set, you name it student, and you have another entity set, you name it professors. So yeah, but this is many-to-many relationship, not one-to-many. I can see it because I see that one professor can teach many students, so it is M from here. And one student can be taught by many professors, so it is M and N. You get it, Kura? So I don't know if this is what you want or maybe you need something with 1 to M, yeah? Is it correct?
Yeah, sample like that where I put
Yeah,
the
because
1.
this is, I can see it many-to-many relationship. But you see why I find it many-to-many relationship? Because the student is taught by many professors, and professors is going to teach many students. So let's say you want an example about, employee, the same example that we have in the department. So each employee, so if we take one instance, this instance and all other instances at maximum, hear this word, at maximum will have a relation with one department. And so in this case, one department, and one department can have a relation with many employees. Is it okay, Kura?
Yeah, thank you for clarifying. Thanks.
Yeah, sure. Josh, go ahead.
Yeah, I was hoping we could maybe give an example of a ternary or higher order relationship, because I found that on the assignment we were having to use one, but we didn't really get too much of an example on that. If we have the time.
Yeah, well, today we will have another example. We will create more AR diagram today.
Okay,
if you talk about more examples. And ternary, it is not widely used, but in some cases we can use it. But normally when we talk about ternary, I can see it as you start with maybe sometimes you have 2 relationships and then you are going to merge them as a 1 relationship. It is not a must that you use ternary, so it depends about how you design it. But when we talk about ternary, yes, it can be whenever we have more than 2 participants, they are participating in a relationship. Again, this is about your mutual understanding for the requirement. But ternary, it is not widely used. Most of the time, you will see a bi-relational ship. But for sure, we will have more exercises today and more. So we will have more exercises about this. Okay, Josh? Paramveer.
So I am confused, like how we can name the relationships. Like, is there any particular criteria?
This depends on you are designer. For example, when I talk about, if I talk this, it's up to you. When I talk about employee and department. So if an employee, I can have more than one name for this. I can say works for, employee for, working in. So it depends. Just you need a description that describes the relationship, but there is no one. There is no one choice. There is more than one choice. All are correct. You got it, Paramveer?
Yeah.
So as I said, in ER diagram, we shouldn't have all the same ER diagram. It is a design. You as a designer, how you see it and how you describe it. But you should be descriptive when you talk about the relationship. What you mean descriptive? Not to give it a label that doesn't describe the relationship. Each one of us has his own description, but you will not give it a name that it is not related to the relationship or the description of the relationship. This is why you should be descriptive, but it's up to you which word you use it to describe the relationship. Can you see my camera?
Yeah.
Yes.
Perfect. Perfect. So today we will continue talking about what is an ER diagram, and we will talk about something we name it enhanced ER diagram, where the concepts of the classes and subclasses is going to be included. If you remember, when we talked about which data model later we are going to use it, we said we will use the extended relational model, object relational model. I'm talking about data model. And I'm still in the conceptual design level. In the conceptual design level, so the ER diagram that I'm going to build should be compatible with the data model, even though I don't have to consider the data model in this level. So if later in the data model that I'm going to use, there is the subclasses concepts. So it should be included in the conceptual design when we talk about ER diagram. So today we will talk about a more advanced options in ER diagram. We will name them as enhanced ER diagram when we talk about subclasses and superclasses. And I think so all of you should be familiar with the concepts of object-oriented. So the same concept will be embedded here. And then the second part of the lecture will be about the 8-step conversion from ER to relational model. So returning back to what we talked about the design level, we said the first one is conceptual. And here the output will be ER diagram or enhanced ER diagram. And then we will go having this ER diagram, we should choose a special data model. In our case, relational data model. So this is a logic design. This is today we are going to do it. The output will be a relational database schema. So in this level, we are going to use the data model, and later we will go to the physical implementation by using SQL queries. This will be the lecture 4. Next lecture, we will talk about this. So today we should finish the conceptual, and then we go to the logical design. So we should reach a point where we can build the relational database schema. And based on this, in the lecture 4, we will implement this using SQL. So in the next lecture, you should already be prepared to have the environment, the exam installed, not for today, for lecture 4. So let's start with the enhanced ER model, which talk about more about subclasses and superclasses. So returning back to the examples that we have already used in the lecture before. So if you have a table employee or a relation employee, we have different instances from the relations. And then we will have, sometimes we will have sub-group of the instances. I'm using the word instances. And later in the table, when we create a table, it will be records, instances, members. So a group of instances, sometimes they have a special attribute or a special relationship they are involved in, and the other they are not involved in. So in this case, it will be a good idea to create a subclass. So for example, if employees are engineer, they have an attribute talk about their engineering degree. So if I didn't create this one, and I add this as attribute here, many instances, they will have a value null because they are not engineer. And sorry, there are some people is in the lobby. Okay. Guys, I think so you are able to let somebody from the lobby to be in, because when I will share my screen, I don't have access to the team directly. So any one of you, if see somebody in the lobby, let him or her to enter the class. I think so you have the option to accept people from the lobby. So returning back to this, if we are going to include the engineering degree here as a part from this entity set, many of the entity instances, which is many employees, they will not have value for this attribute. In this case, if you will create this attribute for this entity set that later it can be a table, then in this case, we will get so much null value. So this is, we name it data redundancy. To avoid this, it will be a good idea to create a standing alone subclass, a standing alone entity for these people. And it will be subclass, which means that it will inherit all attributes that are here, plus the special attribute for this entity set, which is a subclass in this case. And sometimes we have, not only because this group of entity members or entity instances, they need a special attribute. Sometimes they will be involved in a special relationships, like the manager here. So there are a set of employees who are manager, not all of them. So people who as manager, they are somehow, they are only involved in this relationship. It would be a good idea to do it in this case. So if we go here, this is a subclass, this is a subclass, and this is a subclass. And this is a subclass. We forget about D now. So if we have a subclass based on the schema that we are using, I will be back to you, Josh. Give me 2 minutes. If we will have an entity set as a subclass for this employee, we have to use this sign. This sign means that this entity set is a subclass. It will inherit all attributes from here. I don't have to put them again here. Plus additional attribute or additional relationship. Engineer. Here, this engineer, as I said, it is a subclass because it has this sign. And it will inherit all this attribute, plus a special attribute, which is engineer type. Okay, now what about this? if you create a different subclasses for first, and later, and later you find that these subclasses, we can form they have common speciality, like mean that they all are subclasses based on the specialty, like about job type. Here, these two subclasses, they have something common since they talk about method of payment, like hourly employee, salaried employee. In this case, we can group them. So this time we name it specialization, where we can group subclasses or a group of subclasses based on a specialty. It can be job type or method of payment. It's just to make a grouping for the ER diagram. But the fact that talked about subclasses, it's based on this sign. You don't have always to do subspecialty. So I can draw them without this, making for each one like this. But sometimes to make it the ER diagram more understandable, I should group these subclasses like this one under the same umbrella. So since they have a specialty, this is, we name it specialization. So we have inheritance, which talks subclasses. Whenever we have an entity group of instances, they have a special attribute, and each one of them will inherit these attribute plus the special attribute. So in the technician, we will have all this attribute, birth date, address, plus technician grade. In the secretary, we will have all these attributes plus typing speed. Why I have to do this? Because if I didn't make secretary here, and I added here typing speed, so in this case, many employees will have a null value for this. So I'm saving null value in my database. So this is why it will be a good idea to create its own subclass and assign this special attribute only for this subclasses or this group of employee. Go ahead, Josh.
Oh, my question was just simply why the manager wasn't grouped in with the job types with the rest of them, but you pretty much answered that.
Okay. So this is based on the specialization, as I have already said. So specialization means that whenever we have a group of subclasses, they share some specialty, then we can group them to make the ER diagram more understandable. There are further usage for specialization, but in this level, in this course, I think so you should be aware to this level that specialization is just a grouping of subclasses for the reason of specialty in this case. But we have to think first about the subclasses, why we need to have this subclass based on a special attribute or special relationship. And then if we see that there are more than one subclass that they share the same specialty, in this case, we can group them under the same umbrella. We name it specialization in this case. It is very important to consider subclasses when there is a need for this. As I said, to avoid redundancy. Because is this a special attribute? If we put it in the superclass, then I said in many instances they don't have a value for this, like typing speed. Engineer, they don't have a value for this. Technician, they don't have a value for this. Manager, they don't have value for this. And in this case, because it will be a record, and in this case, this attribute for this record will be null. A few of the instances, they have a value for this. And null is a value. Null is a value. So we are saving a null value which is in this case, we name it data redundancy in this case. Any questions so far about specialization and subclasses? Okay. As Papa said, and this is what we have already discussed, that entities that is member of subclass inherit all attributes. This is what we have already said. And also inherit all relationship of the superclass. So the manager here inherit all attribute. And if an employee is involved in another relationship, it will be the same like as if manager involved in this relationship. So a subclass will inherit all attributes and relationship of the superclass. The same concept of object-oriented. When you create a subclass, and it will inherit all the attribute of the superclass with all functionality of the superclass. The same concept here. Generalization. Generalization is a reciprocal of specialization. We said in specialization, we create subclasses, and then we find that these subclasses, they share specialty, then we put them under the same umbrella. Generalization, I create an ER diagrams, an entity set, an ER diagram. And later I found that these entity set, I didn't create them as a subclasses. I didn't create them as subclasses. I create them from the first time as a standing alone entity. And then I said, okay, these two entity set, it seems that they have some common attributes. Like I form car and the truck, and then I said, okay, I have here vehicle ID, I have license plate, and then I have here a price. So, and I have here price, license plate, and vehicle ID. So they have common attributes, and they are so much common attributes. So they have, this is 3 out of 5 are common attribute in each one of them. So in this case, I can consider creating a superclass and add the attributes in the superclass, and then this is again and then I can add them. This is car and this is truck as a superclass, as two subclass from here. Again, I put them in the same umbrella. It is optional. You can do it, and you can, if you don't want, you shouldn't. You can not to put them in the same umbrella. But I see the same umbrella. They talk about specialty when I talk about it, so I put them in the same umbrella. And the aim, yeah, Paramveer, I will be back with you. So the aim in this case, why you need to make generalization, not to avoid redundancy, to avoid duplication. Because if I will not create here this subclasses, and I added the attribute here by typing our engineering grade here, engineering type, sorry. So if I will not have this here, and I will not have here, so I should have two attributes here. The first one about typing speed, and the second one talk about engineering type. In this case, there are many employees have null value for this. So in this case, it is redundancy. I am saving redundant data. And here, if I didn't do this, I keep it as it is. So I'm saving the vehicle ID, license plate number, and in different places. So I will create here a table later and put the value, the 3 values, the price, vehicle ID, and here. And here I put to create another table later, and I put the 3 values here. So I'm making, say, I'm allocating 3 attributes in each table. So this is its data duplication. I can put, in this case, create this vehicle, put the whole data here, and then create a table with 2 attributes here and table with 2 attributes here to avoid data duplication. And because in database, storage is a high factor that we should consider. Because even though nowadays we have a database management systems that give us huge storage or cloud-based storage or online storage. However, whenever you have a more bigger data, you have more complexity later to search and analyze this database. How we can select or insert or update or delete the data. So you should avoid redundancy and duplication in your database design whenever you can. And later we will talk about normalization, because still, even though after we do this, later if we build the relation database schema based in ER diagram, still we have some data redundancy that we should avoid it. And this will be the next step after design when we talk about normalization. How we can refilter, restructure our database to double check if there is any redundancy or duplication that we have already missed to reconsider again. Go ahead, Paramveer.
Why we use like particular D at this set?
Sorry?
Why we use the D for the grouping?
This D?
Yeah.
This is the same one we use this here.
This like,
So it is. I group them because I believe that they share the same specialty in this case, which means for me and for example, both of them talk about they are subclasses based on the body type. You got my point? Body type.
so we have to use the particular D, right?
If you believe that these subclasses they are being a subclasses based on a specialty, it is an optional to include them under the same umbrella, which is D.
Okay.
Like as we did here. Because secretary, technician, engineer, first, this is a subclass, 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 this is a subclass. I can't avoid the D and make all of them like this. This is also correct. However, for a better design, since when we talk about ER diagram for a database, maybe in this database you have 40, 50, 60 entity set, 70, 80. Sometimes we had 100, we have 200, 300 entity set, huge database. You should do your best to make it more understandable, to make it more clear. So if you believe that these subclasses, they share a specialty, like here, they are a subclass because of job type, so I can put them in a D. Here they are subclass because they talk about method of payment. Here they are a subclass because both of them talk about the vehicle body type, car, truck. You got my point? Maybe later I will create another subspecialty talk about fuel consumption, or talk about maybe about the consumption type. You got it, Paramveer?
Yeah, but like why we are only using the D letter?
Yeah. So is it clear for you now?
Like, is there any full form for D? Why we are using the D alphabet?
Wait. It seems that you didn't understand what I said. So tell me what you have already understood to start from there.
So I didn't understand like D is used for the groupings for the same bodies.
That's correct. To grouping the same to the grouping set of subclasses that they share a specialty. You got it?
Yeah.
So here, this was optional. I can avoid it. I can make it like this. But for clearance, for a more understandable ER diagram, I believe that these two this is a subclass 1, subclass 2. Both of them, they share the same specialty. They talk about the vehicle body type. So I said, let's put it in D in this case, which means make them a grouping. Because maybe, I'm not talking about this ER diagram. Later I have another subclasses that talk about consumption type, or they talk about like electricity car or a gas car. So I will make a grouping for them again. You got my point, Paramveer?
Thank you.
So again, this is a specialization. It is optional to do it. The main concept is to create a subclasses, this one. If you believe that these subclasses, they share a specialty, then you can group them using D. If you believe that they don't share specialty, you don't have to group them. Generalization talk about that I don't have a subclasses, I don't have inheritance. I have entity set 1, entity set 2. But I believe that they have common attribute. So I said it will be better to do it like this in order not to have these 3 attributes in 2 different places to avoid duplication in this case. Okay, if no one, we will have our first exercise before we go to part 1. So the exercise said, sketch the ER diagram of a real estate system. I will discuss it with you, and like always, I will distribute you to different groups, and then you will have your internal discussion, and then we'll return back to the main room to discuss the solution. So sketch the ER diagram for a real estate management system that control information about customers, properties, and the sell and buy procedures. That are done in a company. And then it's talk about customers, it talks about properties, and talk about sell and buy procedures. So there's 2 operations here. Each property had a registration number at the ministry that is dedicated for the property, which could be a house or a land. Each property has an address that contains the street, city, and postal code. For each land, we should register the access road. However, for a house, we should register number of rooms. Each buying operation will be accompanied with detailed bills that contain the date of buying of the property, the total price to be paid, and the different payment that the customer should pay with a due date for each payment. Each payment has a number and is usually related to a given bill. A customer has a unique SSN with different phone numbers. However, a phone number can be related to a single customer. This is no need for the and here. There is a type of mistake here. Okay, I will ask you kindly to take a screenshot for this because you don't have this in your PowerPoint that you have so far. You don't have this in the lecture that you have it. So take a screenshot if each one of you about this. Have you already all taken a screenshot for this? Give me 3 thumbs up. I will distribute you and I will break you down for different groups. You will discuss it. A hint that you should use enhanced ER diagram here, not only the ER diagram. So based on what we have already discussed the last time, and today, you should construct this ER diagram. So I will break you down and then I will pass by each group of you. So let me break you down. Is it the same group that we have it there? Move all existing room. I will create new rooms. I don't want to have the same rooms automatically. You should be now, yeah. Rapun, why you are still here? Rapun? Hi, are you all here? Should be closed.
Hello?
I'm waiting the others to be closed. Why, I don't know. I see that we all are here back. Yeah, it was a good practice, yeah. Let me share again my screen. Can you hear my voice?
Yes.
Yes.
Yep,
Is it clear or there is an echo?
It's clear.
Clear.
it's clear.
Perfect. So let me share my screen again. Before we go to the solution discussion, discuss a solution. Any one of you want to discuss the question or the requirement? Most of you can understand the requirement. Okay, so is there any group want to share the solution with us before I share my solution? Is there any group want to share the solution with us? No one want to do it?
I can maybe share mine.
Who's this?
Elijah?
Okay, go ahead, share it.
Can I post it in chat, actually? My computer is really slow. I posted a link in chat. Can you open it on your screen?
Okay, we can do it. Okay, let me because I'm sharing a screen, so I should now stop sharing and share. Okay, let me share. I will share my screen, not yeah. So I think so we can see your solution now.
Okay, yeah. Should I go over what I did?
Okay.
Yeah, so each property has a registration number that identifies it, and both land and house are entities that are subclasses of that property.
Okay.
Originally, I had the buying operation as a relation, I think, the diamond. But because there was so much information associated with that buying operation, I decided to make it an entity. Customers can have multiple phone numbers, and the SSN identifies the customer. The selling operation, I didn't have time for that, so I just quickly did a sell date.
Okay.
And yeah, the total price was inferred from the sum of payments. You don't need to have a separate attribute to keep track of that. You can just sum the payments, and that'll give you the total price. And I think everything else is pretty self-explanatory. Oh yeah, the purchase and sell diamonds, the relations, they're only one. Like one customer buys one property, because I thought it'd be more sense to have separate instances. Oh yeah, okay, I'm done. Yeah.
I see that you are. This was perfect concerning when talked about customer property. You make composite attribute here. You make subclasses. Everything perfect. Sell by. But what I can't understand, payment 1, 2, 3. Maybe you have 5 payments, 6 payments, 7 payments. What you are going to do in this case?
Yeah, so each payment needs a different payment number, but I didn't know.
Yeah, but when you create an ER diagram, this is a fixed number of entities, so you are going to create a table later for each one of them.
Yeah, so there is some redundancy I need to.
So in this case, payment. In this case, payment should have one entity. We name it a payment.
Okay, so a separate entity. Okay.
Yeah, at a separate entity. It is not an attribute. Whenever you feel that a special concept, it has more than one attribute. So the best scenario in this case to create an entity set for this, which is a payment. The problem with the payment that this payment, it doesn't have because even though payment number, which is payment 1, 2, 3, it is not unique. So it is a first payment for this bill, second payment for this bill, third payment for this bill. So you need to have the bill number and the payment. Because when you talk about a bill, you have an invoice, and then the owner of the house or whatever, he or she will tell you that, okay, you can pay this bill using 3 different payments. So the payment will be always related to the bill, because it was mentioned that we have something we name it a bill. So I think so you have already missed the bill here. And the payment, since the payments, and this is for all of you, if there is an attribute, we feel that this attribute, it has more than one more related attribute, like due date and number. And in this case, we should create an entity set, standing alone entity set. Now the question, is it going to be a weak or a strong one? So if we can't create a key for this and it is related to another entity set, then it is a weak one. But I can see it here. We have a payment 1, 2, 3, 4 because we don't know how many number of payment we have. It depends later. So this is why creating a table for this or entity set, so we can create different payments based on this entity set in this case. It was a perfect job. It was amazing in this short time that you know how to create the properties and then how to make it subclass, perfect, customer perfect, buy and sell. And I have something with the cardinality for buy and sell. You said 1-to-1, which means that you as a customer will never buy more than one property.
Can you do separate instances in the database?
No, why I have to make a separate instance? In this case, it should be many. Why I have to do it one? You as a customer can buy more than one property, and the same property can be owned by more than one customer. So it is many-to-many relationship. It is not one-to-one relationship.
Can multiple customers buy one property?
Sure.
Okay.
This is always happened. Even though it is not maybe mentioned clearly in the requirement, but this is something very obvious that always property can be owned by more than one person. But it was mentioned that a property, a customer can own more than one property. You can have a land, a house, you can have 2 lands, 3 houses. So in this case, it is many-to-many relationship. The same for the purchase, the same for the sell. So I see both of them, they are many-to-many relationship. Do you agree on this?
I agree with it, yeah.
I want to thank you so much about this. Let me see if somebody else will have a question before I go to my. So if Josh, do you have a question, or you want to share yours?
Yeah, so I just wanted to share mine because our group did 2 different versions because we weren't sure if Bill would be kind of a weak attribute.
So what about sharing mine, and then I will share yours? What do you think?
Okay, sure.
Okay. So if I will go to the requirement to see how I can do it in my case, the procedure will be first that I have to see how many entity set I have. Like what happened with our colleagues now, they are somehow confused about the payment. Is it an entity set or it is an attribute? So first I have to agree about how many how many entity set I have. So it controls customers, operators, sell and buy procedures. It talks that this is a procedure, somehow it is an operations. And each property had a registration number and is dedicated for this property, which is a unique, and could be a house or a land. Each property has an address, contains the street and the city and the postal code. If I read this, I'm quite sure that property should be an entity set. And quite sure it has a key, it's going to be a strong one. And it has an address, street, and it has an address that has a street, city, postal code. However, I'm not sure about the house and land so far. So somehow the house and land still I'm confused about them. Let's continue. Each land which should register the access road. However, for a house, we should register number of rooms. So I have a special attribute for the land, a special attribute for the house. And both of them, they can resemble set of instances from the property. According to the definition, it seems that they are a subclass because they have a special attribute. A subclass, it is a group of instances or an entity set that they will need their special attribute, or they will be involved in a special relationships. So in this case, it seems that I have a subclass and land, so I can see that I have a property as a strong entity set. I have a house and a land as a subclass of this. Let's continue. Each buying operation was combined with a detailed bill. It is a concept. So far, I don't know if this is going to be an entity or not. I don't know. That contain date of buying of the property, total price to be paid, and different payments. So it has more than one attribute. So in this case, it can make an entity in this case. And then it said it has a due date for each payment. Wait, there is a payment now. So I don't know if what kind of an entity. Is it an attribute for the bill? But it has more than one payment. And I don't know how many number of payment. And each payment, it has its own attributes. So it is a standing alone entity set. If we have more than one subclass, we can think about subclasses with special attribute. I'm talking about 2 entity set related to each other. One of them, it has its own attribute, and the other one, it has its complete attribute, which is the bills. And I can form to it a strong entity because a bill can have a unique number. Invoice always has a unique number. However, the payment, it doesn't show us that this payment related to this bill, and the number of payment can vary between bill and for another bill. A customer has a unique SSN with different phone number. So it can be different phone number. You see it? So I can have for the same customer more than one phone number. So it is a multi-value attribute. However, a phone number can be related to a single customer. So I have for the same customer more than one phone number. So again, I started with the main entities. then put for them their attributes. The phone number is derived because more than one phone number for the same customer. And then as we have already agreed, we have a subclasses, land and house of the properties. And then I put them the attribute, then I put the attribute for this bill and the attribute for property. Here I have the property number that is unique from the ministry, as we have already discussed. Now, after I finish the class, the entities, the subclasses, and I see if there is a weak entity, which is a payment, I see it as a weak because it doesn't have a unique number. If I will have this payment for this bill. So the bill number with the payment number, both of them payment 1, bill 234. So now they are unique. So it is a weak entity in this case. After I finish all entities, weak, subclasses, strong, and put their attribute, now I start thinking about the relationships. So the next step is the relationship. I have a buy and sell, and the requested price, I add it as an option, even though it is not somehow it is an optional one based on my understanding, even though it is not clear in this. So if you didn't add it, it will be okay. Don't be worried about this. But it is many to many relationship because a customer can buy more than one property. A property can be owned by different customers, and the same for the buy also. Josh, go ahead now. You want to share yours or you want to discuss this?
I'd like to start by discussing that because I do have a few questions about this.
Go ahead.
In our prompt, we're not given a bill ID, so we're supposed to assume there's a bill ID because that was one of our confusions in my group was that we thought the bill would be a weak attribute then because we didn't have anything to differentiate it. So we tried to make it, we tried a few different things, but we weren't sure how to actually make it a full entity.
Sometimes if there is an entity set, which is an obvious one, that in our in real life, it is obvious, it is a standard. It will be not included in the requirement. So based on the normal life standard, there is a bill ID. There is nothing a bill without a bill ID. But again, if you believe that it is not mentioned, you make your own assumption, this is correct. But it was not mentioned in the requirement because there is no bill without an ID. Because this is standard. Always, when there is a bill, there is an ID. But if you believe that you have your own assumption because it's not mentioned in the requirement, this is also correct.
One other question here. So I see that customers are selling property, but what if someone doesn't buy a property? Are they still then a customer when they're selling the property, right? Because this could be just sold by a landowner.
Yeah,
and
this is correct. This is correct. This is why it is not a full participation here.
Mm-hmm.
If it is a full participation, means that all they have to buy. And this is not the case.
Because I put in that customers all buy because
this is why I didn't mention this is why I didn't mention full participation here.
Okay.
I make it partial, which means that maybe some of them they sell, not buying, and some of them buying, not sell, and some sell and buy. So this is why it is a partial one, not a fully participant here. You are okay, Josh?
Yep.
Still, you want us to share yours and discuss yours, or you are okay?
I think it should be fine.
Okay, I think so. Ivan had his hand before Navipon. I will go Navipon. Ivan, do you still have a question?
No, I was just going to add, I did not find bill having a bill ID to be obvious either. I did not find that very obvious.
Okay, so you mean that it should be included in the requirement?
Yes.
Okay, I can agree with you on this, but as I said, so in business rule, there is no bill with an ID. It is not obvious from the requirement, but it is obvious from the concept of the bill. There is no bill. There will never that you can find a bill without a number. Is it correct?
Well, I don't know. That's why I'm asking. I don't know.
Yeah, so according to accounting standard in the whole world, there is no bill without a number. because if it will be without for tax issues, it is illegal. It is illegal to give a bill without a number because you have going to declare it and they have to trace it for taxes issues. But again, I agree with you that maybe it was better to include it as a requirement. Is this answer your point, Ivan?
Yes, thank you.
So I will go to Navipun first, because I think so she's the first to raise her hand. He or she, I don't know, sorry. Navapun, go ahead.
Hi, Professor. Yeah, okay.
Go ahead.
So for the payment entity, is it, why is it not a subclass of bill? For me, is it like subclass of bill? So for, in your answer,
payment,
yeah, this one.
Subclass of what?
Of bill.
Of bill.
Yeah.
A subclass mean that it will have all attribute plus additional attribute. A payment doesn't have date of issue, doesn't have total price. So it is not a subclass. A subclass means that it will have all attributes plus additional attribute. So employee manager, because when we talked about employee has its name, it has date of birth, address, it has social security number. So a manager is an employee plus additional specialty or additional attribute like manager to which department or involved in a relationship with a special entity set. A secretary is an employee. It has an employee ID, it has a social security number, date of birth, address, all the attributes of employee plus typing speed, which means that talk about an additional attribute. But the payment, it doesn't have all attributes here, so it is not a subclass. It is a standing alone entity, however, related to this, because to create a payment, you need the billing ID first.
Oh, got it. And okay, and next question for the contain diamond app, the one over payment box. Why there is double
this
line?
One?
Yeah. What is the definition of double line?
The last time when we talked about weak entity, do you remember weak entity? This is a weak entity. Weak entity means that we can't have a key for this. This is and this is, both of them. I should put a line, by the way, here. I missed this. This is and this, both of them, but I didn't put it not to be confused, will make the key for this. So whenever it is a weak entity, then we will make a double line, and the relationship with the entity set that identify it or support it, it should be double line.
So we should put double line in both entity and the action
Not
and
both
the
entity.
diamond.
Not both entity, just double line in the weak entity. And the relationship with the strong entity that support it, identify it, the relationship between them should be double diamond.
Okay, got it. Thank you.
Sure. Simran, go ahead.
Hi, Professor. Shouldn't there be full participation from the property entity in relationship selling and buying?
Here?
Yeah.
So suppose you have a property that this company own it, but there is a customer that has already buy it, but there is no customer is going to sell it.
Right.
So in this case, it is not all of them it will be involved in this case, so it is a partial one.
Okay, right. I also have one question. Can we add a specialization under property as type of property?
Yes, you can.
Okay, thank you.
You can. You can add a D here because you can do a specialization here. Yes, you can do it.
Thank you so much. Thanks.
Sure. So Josh, do you have another question? Or from the first time you are holding?
Yeah, I had a question. I just completely forgot it for a second. So you had mentioned earlier that ternary relationships weren't very common. So I was wondering if there was a way to show this without.
They are not very common. They are rarely used.
Mm-hmm.
So most of the time
That's what I was saying.
yeah,
So
yeah, go ahead. Maybe I missed what you have
I
already
was
said.
just gonna, yeah, I was just gonna ask if there was a way to show this without a ternary relationship, or if we should show this with a ternary relationship.
So this is a ternary relationship. This is a bidirectional one. This is correct?
Yes.
So if you don't want going to make a relationship as a ternary, but this is ternary, it's again, Josh, you should be aware that we are talking about very simple cases ER diagram, but this is not a reality. If you want to make a real database system, you will have maybe hundreds of entity set. So sometimes this is why we talk about specialization, something like us. It will be better that if to combine different relationships to have more clearer entity relational diagram. But if I don't want to make it a ternary one, I want to make it a bidirectional. In this case, I will make a relationship between here, and then I will make a relationship here. And then in this case, a customer, by using a bill, and a bill is for this property. It will be like this, Josh, in this case. You got it, Josh?
Okay. Yeah, that sounds good. Thank you.
Yeah, but doing this in this case, it would be a more clear and better. Do you agree?
Yeah, for sure.
I think so. Can you raise your hand and then you lowered it? Do you still have a question?
No, sir. Thank you. It was already answered.
Okay. Let me double check something in the chat. Maybe I missed something. Josh, Josh said, what if we want to do an illegal? What do you mean for the bill?
Yeah, I just meant for the bill. It's just a joke.
So yeah, I know, but yeah, it's still people do it illegal, but they do it as they make a double book. So illegal system will be having a double book, which means that you will have a transaction, parallel transaction. Still, you have a bill ID, but you have the official bill ID and non-official bill ID. So even though if we do it illegal, we still need the bill ID for the non-official one. And to be honest, there is a lot of software they use something they name it double box. It is illegal software because whenever there is a double box, which means that you have some transaction go to this book and some another transaction go to this book, and then you are going to to use for tax filing the first book, and you don't show the second book for tax filing. Okay, even though I was planning to have a break, but I think so we don't have so much time. And during this discussion, and we need to have this discussion, I think so it was healthy to have this discussion. And I'm extremely happy to hear always the questions. And sometimes if I can't answer in a correct way, I will be happy to repeat it and maybe to use other way to clarify it for all of you. I don't want anyone to be shy about asking questions. Go ahead and always ask whenever question you want, because sometimes the question you will ask, it will be beneficial not for only you, for the other teammate, because having this interaction as a discussion will clarify the idea for all of us. So now, after we have already practiced this, the next step is, so now we have the ER diagram. What is the next step? Returning back to what we have already discussed about the different phases in database design. So the first phase is conceptual, the second phase is logical, and then we go to the physical where we implement the files or the tables. So the conceptual, which is the enhanced ER diagram, so far we have already done it. It's talk more about what is the different concepts we have or entities and their sub-entities as we did today, and what is the relationships and what is their attributes and what different types of attributes. This is all what we have already discussed here. So the next step is I have to choose a data model. And I have to build my database schema based on this data model. At the conceptual level, we didn't consider the data model. Even though we said the entity enhanced entity relation diagram is somehow compatible with object relational model. But at that level, when we create the entity relation diagram, we didn't consider the model, the data model. We said we have different data model, if you remember at the beginning of the first lecture. So now we have to choose a special data model. And later, based on this data model, we have to choose a special database management system that's compatible for this data model to create physically the relations of the tables. So in our case, we use a relational model, and to be more precise, the object relational model. So how I can make this conversion or make a mapping between what I have already done it in the ER diagram and the relational model. There is 8 steps, the 8 steps that you should consider. I name it 80 steps. Some other, you can find different procedures and different references. Based on my old experience, this is the simplest and the most completely procedure that we can do it to transfer the ER diagram to a relational model. So, and even though in this is just came to my mind, I'm using more than one book as reference in this course, not only one book. And I'm doing my best that I have different references I added at the beginning of the lecture. Again, the lectures note, they are more than sufficient for materials. Maybe you double check online to have more exercises, but all what you needed as a concept, you can find it in the lecture notes, because they are based on different references, not only using one reference for you, to make it more clear and more complete. So, as I said, so we are now here. We should go from here to here in this case. So, to our relational tables, the use of, and later, we can use the data normalization technique to test the table resulting from this conversion. Is this convert the tables that we got it? Is this the optimal? Or we need, this is, we do it later in data normalization. I think so it can be starting lecture 5, according to our plan. So the first step says that if in your ER diagram, you have to look at the strong entity you have. Don't consider the relationship now. Don't consider the relationship, forget about it so far. So I have to think about the entity. As Papa said, we will consider the relationship later. So we have to consider the strong entity set we have. For each entity set, we should create a relation, which is a table in this case. So here, I will, a relational database schema, it is the name of the table or the relation. We name it a relation because we believe that this table is a group of attributes talking about the same concepts. It is a relation. And then we should have the list of all tables and the name of the attributes in each table. Plus, later, next lecture, we will add the data type. Now we will not add the data type. And we have to mention the primary key and the foreign key. We will talk about the foreign key today. So first, I have to go to each strong entity and create for this strong entity the table for this. And then we will add the attributes and we make the same underline the primary attribute. So far, nothing being changed, just we create tables or relations to each strong entity. Now we consider the weak entity. So the weak entities, we will create the table for the weak entities as we did here, and we will add the attributes plus the primary attribute of of the identified entity that is supporting to this, in this case, host name. The host name, it is a foreign key here, foreign key. And there is another note, when you create this relation or a table, you may change the name if it is here, or you can keep it as it is. Like here, I change the name of the attribute. Sorry. So here it was a name, I'm making log name. Sometimes in the ER diagram, because when it is in the ER diagram, it is somehow related as an oval to this entity. Here we will have them as a list. Sometimes it will be a good idea to change the name. It's up to you. It is option. So again, I put a name as a login name here. I put a name as a time here. And I added the primary key of the identified as a foreign key. I don't have to put a line. I will tell you later about the line. So a foreign key, here's this definition. A foreign key is a copy of a primary key of another entity or another relation. So it is a copy from this. Later, when we will write the code, we will see how we can write the code for this. So this is referred to this attribute. This attribute refers to this. It is a copy of this. And after I added as a foreign key, both this and this, both of them will make the primary key to logins. So this is a foreign key. And now, since it is a weak entity, this plus this, both of them, will make the primary key of a logins. This is why I make a dash here. So step 3. Now we have to consider the relationship. Here, we create this relation, we create this relation. We take the attribute as they are, put here. We have 3 attributes, put 3, we have 2, 2. Now we are going to consider the relationship. Now, when you consider the relationship, if now the cardinality, now it has a job here. If it is one-to-many or one-to-one, in this case, you have 2 options. Either you will add the primary key of the command as a foreign key here, which is a copy as a foreign key, or you will add this as a foreign key here. Both are correct. You don't have to do the both. Choose one of them. If we have one-to-one relationship, and in this case, after you create the 2 tables or the 2 relations, since you have to consider that they have a relationship, this relationship, we will resemble it or we will consider it in a way that we will make a copy of a primary key of a 1 and the other one as a foreign key. This is a foreign key, not a primary key. There is no dash here. No dash here. It is a foreign key here. So either I put this as a foreign key here, this is option 1, or I will put this as here, it is option 2. Both are correct if you have a one-to-one relationship. This is considered full participation or partial participation has nothing to do in this schema here. It was just for us to understand more about the flow and the relationship. However, when we go to the schema, we don't have to consider the partial and the full participation, but we have to consider the cardinality constraints. So one-to-one, I have, again, to either will put the primary key as a foreign, or I will for the first to the second, or from the second to the first. Here I put the first, sorry. So the next step is, if I have like here one-to-many relationship. So first I will create a table for a client. I will create a table for client and a table for command. And then I will consider the one-to-many relationship. Here, I don't have options. I should include the foreign key, the primary key of the one, as he said, include the foreign key of as the primary key of the relation that present the entity from one side and the other side. Who's the one side? This one. So I have to put the primary key of the primaries over here as a foreign key. And if the relationship have any attribute, I will put it in the many side. So again, if I have one-to-many relationship, I will put a copy of the primary key of the one in the many. And if the relationship have any attribute, I will add it in the many also. So in the many side entity, we will have the attribute that we will have it here, plus the attribute of the relationship, plus a copy from the one side as a foreign key here. It is not a primary, no dash. Not a primary, no dash. So in this case, we will have number of the client, and then we have date of the command. So this is a foreign key. Any questions so far? If any question, I'm happy to answer your questions. So Papa said primary key from the one becomes a foreign key for the many. Go ahead, Josh. Go ahead.
Okay. So, Professor, does
I'm sorry, it is Navipon. I'm sorry, I thought it is Josh. Go ahead, Navipon.
Yeah. So, does the care relationship have the have the attribute, the date CMD? This one?
Yeah, this is what we have already discussed the last time. A relationship can have an attribute. Yes, this is the case. You were there in the last lecture?
I didn't remember on this part, but never mind. Okay. So.
Yeah. A relationship can have an attribute, and why? Let's tell you why Navipon we have this attribute. We can return back to this. Sometimes an attribute, it is not related to a command directly, because sometimes this attribute will never happen if this relationship was not there. Like, if the client will not make a command, there was no date for the command. So this is why I put it here. But finally, it will be here. In all cases, it will be here. So sometimes we said there are some attributes, we can include them in the relationship because they are more related to the relationship. But in the schema, it will be now in the the entity set in the many side in this case. Is it okay, Navipon?
Okay. Thank you.
Sure. We have a question here. What are the relation schema that we got from the following ER diagram? So you have 4 options. So if I want to, this is an ER diagram. If I want to convert it to a schema, which is list of tables with their attributes, which one is the correct? A, B, C, D. You have 1 minute to give me the answer. So, any answer for this? Okay, I have Simran. So wait,
I believe
wait,
it's.
yeah,
Oh, sorry.
wait. No, just raise your hand and then let's give more time to the others. Go ahead, Simran. I will start with Simran and then I will hear the other. Yeah, go ahead, Simran.
I believe
Simran.
it's C.
You say C. Okay. Asira. Asira, you raised your hand, so you write something in the chat? Let me check it. No, you didn't write something in the chat, Asira. So, Harmandeep.
It's C.
C. So, Paramveer.
Yes, it's C.
Josh.
It's C. Did you want a reasoning for that or just?
Yeah, we
say
will
what-
discuss it now.
d-
So, Kawaranjit or Kanwarjit said C. Okay, go ahead, Josh. Let's discuss it. Yes, it is C.
Sure. So for one, the answer was actually on the slides.
Okay.
Yeah.
This is, you know why sometimes I don't want to share the slide because sometimes this is a point.
Yeah. But the
Okay.
reasoning is that we have two entities here. So A is automatically just canceled out because it has one of the relationships as an entity for some reason. And then
Okay. So whenever it is a one-to-many relationship, we didn't consider to create an entity set for the relationship.
Mhm.
We just create an entity set, create a relation to the entity set we have. So we will not, this is incorrect.
Yep.
And now we have three choices, this. So the rule said you should include the primary key of the one side as a foreign key in the many side. So here we have ERP name, this is a primary key. And then we have added here, which is, this is correct. Here, what about this one? Here, we added the ERPs, this is correct. However, we added also for the many here, this is incorrect. We add the primary key of one to the other, so this is incorrect. We add ERP here, this is correct. However, we also add sub ID to here, and this is incorrect. So, what about this? Is we said incorrect because we create a teachers, so it is incorrect. What about this B? The B, we didn't add ERP as a foreign key here, so this is why it is incorrect. So this is C, the correct one. Any question for this? Navid, do you have a question for this? It seems no question for this. Okay, let's go. So what if we have many-to-many relationship? What if you have a many-to-many relationship? What we are going to do in this case? If you have a many-to-many relationship, and sometimes maybe we will have a primary, we will have an attribute here, maybe not. So in this case, we should create, as we said before, an entity for a relation for each entity. However, we will not share the key here. We will create a table for this one. So we create a table for client, we create a table for product, and then we're going to create a table for a buy. And in this table, we will add the primary key of each one, add a foreign key. Both of them, they will make a primary key for buy. And if we have any attribute here, we will add it to this relationship in this case. So Papa said if in many-to-many relationship, we need a relation by itself to the relational model. A question, even though the bad that you have an answer here. I should double check again when I share with you, don't have the solution for this. So now, don't see the solution. Give me the answer. Be honest. So what will be the answer for this? A, B, C, D. Who is going to give me the answer and also discuss why this answer? Why? So the first is Josh. I will wait more for the others. We have Kura, Simran, Harmandeep. Josh, do you accept that I let Kura first discuss it? Do you accept this?
Sure.
Go ahead, Kura.
I think it is A.
It is A.
Yeah.
Okay.
I'll double check. Employee ID, e-name, department.
So we have employee, we have a project,
address.
and we have handles, and we have date and hours. That's correct. Yeah. Go ahead.
The address, city, gender, name.
Yeah, this is a problem. So maybe I didn't discuss it before with you. This is why I added this example.
Mm-hmm.
So if it is an address here as a composite attribute, in this case, we will not include this because we don't include address and city and city, either this or this. And since we need this, so we will not include address. So A is incorrect.
Okay, can I change my...
You can change, yeah, go ahead.
Okay, so without the address, I cannot read it. Wait. It should be name, department, street, city, gender, name, country, client, cost, letter, handles, employee ID, name, date, hours. I think it's D.
B. I think so, you are correct.
Yeah.
Josh, are you still here?
Yeah, I'm still here.
So it is D for you also?
Yep.
Okay, what about Simran Harmandeep?
It's D for me too.
We have two Simran, so both of you, you have D. Okay. Yeah, it is D. Let's discuss why it is D. So it is D because, as we said, first we are going to create an entity for a relation for each entity and put all their attributes. However, we have a special case here. We have the address as a composite. And if it is a composite, in this case, we have to include all attributes here, as we did here. And then we have to create a relation for the many-to-many relationship, which is the employee ID and the project name and the date and the hours. And this is incorrect because we didn't include the primary here and the primary here as a foreign key. So it is incorrect. This is incorrect because we add the address, we didn't add the attribute of the address, so it is incorrect. And this is incorrect also because we add the address and the attributes here. So it is incorrect in this case also. Josh, do you want to add something?
Yeah, I was actually just curious about the address being a composite attribute. Would we be able to get away with putting address and not street and city since they are included within the address?
Okay, if we put the address here, now where is the city, street, and city?
So those are included in the address, right? That's what makes up the address?
Where they are included in this schema. I can't see them. If you want to do this, then you should create a table, you name it address, you put in this table street and city, and then you should put the employee ID here as a foreign key to make a relation with them.
Okay.
But there's no need for this, because for us, the address, the sub attribute of the address that we are going to make a data entry for this, it is street and city, which they form the address. Do you agree on this?
Yeah, that's kind of what I was getting at, is that they form the address, and that's why. What if we just did the address instead of having it street and city? That's all I was asking. But yeah, okay.
Okay. Step 6.8 say talk about multi-value attribute. If you have a multi-value attribute, we talk about the composite attribute, but what about if you have a multi-value attribute? In this case, for the same entity instance, we will have different values. The same customer will have more than one phone number. The student the same student will have more than one degree. So the rule said that you will create a table. Sorry. So the rule said that we create a table for this, and where we will add student, and then we will add a student degree here. A student, which is a table that for the student ID, name, and birth of date. And then we will have a student degree, where we will add the degree as an attribute, and we will add the primary key as a foreign key here. Both of them should make the primary key for the student degree. I'm sorry. Let me check. So this is the last, no, not the last step, 7.8. It will be whenever we have a ternary relationship or an array relationship. In this case, we are going to create the same as we did to many relationship. We are going to create a table for this. So we'll create a table for entity A, entity B, entity C, and then we create a table for R in this case. So the least one is subclasses. So how we are going to deal with subclasses in a relation database schema? So if like the examples that we had before, so the subclasses, the subclass is a standing alone entity. However, it has all attributes of the superclass. So we will create an entity set for each one of them, like vehicle, car, truck. And now for the car, we have to add the attribute of the superclass, which is like here, price, license plate, vehicle ID, and maximum speed number. It seems that I hear. It seems, sorry. We have to add the attributes of the primary key of the superclass, which is the primary key here. I added here as a foreign key, and also will form the primary key in this case. So I will, whenever we have a subclass, I will create an relation for each one of them. I will add their attributes plus the key of the superclass. I will add it as a foreign key here, and will make the primary key in this case. Now the question that this is the last question for today. It will be based on what we have already done in the first part. I ask you kindly now to make another. I know that. Yeah, still we have time. So I will ask you to make a screenshot for this. And now I will ask you, I want you to convert this that you have already constructed as an ER diagram to a relational database schema using the 8 step. Do you have, make a screenshot? Do you have any question before we go to the exercise, and then we'll be back to here? Any questions so far? Okay, I will break you down If you want, I can use the same rooms. I'm not sure if, yeah, I still have them. So I will, maybe I can do it here. I can go here to the rooms. I can reopen them. Yeah, I can do it. Please take a screenshot for this. I see that still I have some people, they are not in a group. Oh, there's a group, I didn't open it. For Mac, but I think so.
Okay.
The simpler you can use also another version map for Mac.
Okay, sounds good.
So sure. You just download it. It will come with a database management system. It is the database management system is MySQL. This is our database management system. It is part from this collection. Ivan, go ahead.
Yes. Which one of these would, if either of them, work on Linux?
Example work in Linux also.
Okay.
So I added in lecture 1, I think so. If I go to lecture 1, at the end of lecture 1, I added for you a links. Here it is. You will find the links to download them. So I think so in lecture 1, if you return back, you can find it. For example, this is not only for Windows. It can be, you can have different for Linux and because Apache, it is an open source community. It is the same community like example. Any more questions for today? No more questions? So I need 10 thumbs up to leave, or I stay here. Okay, guys. If you still have any question, just drop me an email. And more practice, we will do it next time. And take care all. Bye bye.
Thank you.
Sure.
Thank you.